Alright, so what we're going to be talking about today is Pythagorean Theorem. How many of you have heard of Pythagorean Theorem before? Okay, a lot of you guys, I think, learned about it when you were in 8th grade, right? Okay, what do you guys remember about Pythagorean Theorem? Raise your hand if there's something you remember that you can tell me. Okay, Aries, what do you remember? Okay, so you're very close. Yeah, a squared plus b squared equals c squared. This is what a lot of us remember about Pythagorean Theorem, right? This formula, a squared plus b squared equals c squared, okay? Now, Pythagorean Theorem has to do with this formula, but it is in regard to a certain type of triangle. Does anyone remember what type of triangle Pythagorean Theorem deals with? Right triangles. Good. Okay. So Pythagorean Theorem works with right triangles. And specifically, what does it mean if a triangle is a right triangle? It has a right angle, which a right angle has how many degrees? Okay. It has a 90-degree angle. Good. Okay. All right. Now, this formula, this a squared plus b squared equals c squared, this comes from, it doesn't just like come like poof, the formula exists. I mean, it comes from the properties of a right triangle, okay? So I don't want you guys to write this down when I'm writing on the white paper or draw it. I just want you to watch, okay? So if I have a right triangle, and it doesn't matter how big or how small I draw this right triangle, okay? But every right triangle has a right angle, right? Okay, now, this formula, this a squared plus b squared equals c squared, this comes from the fact that in any right triangle, no matter how big it is, if I were to take and measure this side of this leg right here, and I were to make a square, like off of this side, and one of the properties of squares is all the sides are the same length, right? And then I were to find the area of this square, I would get a number, right? Like if I multiply this length times the same length, I would get some number for that area, right? And then I were to take this leg over here and measure it and make a square based off of that length. Okay, and then I take the area of this square, okay, and I would get a number for that, right? And so I could do the same thing on the last side. I could measure this side, and I could make a square based off of the length of this side. And I could find the area of this square by multiplying these two, right? Now, what ends up happening in every right triangle, always, 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 is if it's a right triangle, the area of this one plus the area of this one, their area of these two added together is always the same as the area of this one. Okay? And so that's where it comes from, is by calling this side A and this side B and this side C, okay? And knowing that to find the area of this square, I have to do A times, well, this one's the same length, A, right? So A squared. And then this one, B times B over here, right, would give me B squared. That's the area of this square. And then C times C gives me C squared. And these two, the area, always adds up to this one, okay? Now, I'm going to show you like a short little video so you can kind of see, like, if you don't believe me, like you're looking at this thinking, no, Miss Miller, these two are not the same size as this. I'm going to show you a video right now so you can watch and see, okay? Okay, so let's talk about what are legs and what's the hypotenuse. Okay, the hypotenuse, what do you guys think the hypotenuse of the triangle is?
Along
The longest side, okay? So it is the longest side. Okay. It is also across from the hypotenuse, or sorry, from the right angle. Okay, so it is the longest side and it is across from the right angle. Okay, the legs are the two shorter sides. And when I say shorter, I mean like they're shorter in comparison to the hypotenuse. Okay? All right, so if I were to take a look at this triangle here, okay, here's your right angle. This is a leg. This is a leg. And the hypotenuse is across from the right angle. So this right here is going to be your hypotenuse. Okay, do you guys think you can label where all the parts are in these other two triangles? Okay, so go ahead and start labeling them. Okay. Okay, after you label them, if you have a highlighter or like a colored pen or something, maybe highlight or circle or underline the formula. Maybe let's highlight this keyword, which is right triangle, because that's important, right? And then maybe highlight these keywords, which would be legs and hypotenuse, okay? So those are some of the important things. Okay, now, in the formula, there's a spot to plug in the length of two of the legs and a spot for plugging in the hypotenuse. So these two, the A and the B, are always going to be the values of the legs. Those represent the length of the legs. The C is representing the hypotenuse. Okay? All right, so what we're going to do right now is we're going to do just a couple examples together. We're not going to do all of these, so we're just going to do a couple of them. So let's take a look at this one here. If this is your right triangle, these two parts that they gave you values for, are those the legs or are those the hypotenuse? Legs, right? So does it matter which one I call A and which one I call B? It doesn't really matter for the legs. It is important which one I call C because there's only one hypotenuse, okay? So I can call 3 either A or B. It doesn't matter. I'll just call it A, and I'll call this one B. Now, the important part is that I get C in the right spot, and C is the longest side across from the right angle. So C goes over here. Okay? Now, C is missing. Okay, it says find the missing side. So I'm going to write this equation down and plug in the things I know and then solve the equation. Okay, so the equation for the formula is a squared plus b squared equals c squared, right? So what's going in the spot for A? 3. What's going in the spot for B? 4. I don't know what's going in for C, so I leave C as the variable. Okay, now I need to do order of operations, which says exponents before adding, right? So what do I get for the exponents? 3 squared, 9, 4 squared, 16. Okay, what is 9 plus 16? 25. Okay, now I have 25 equals c squared. Okay, that means 25 is not c, it's c squared. So I want to find just c. So how do I get rid of this squared? Well, one thing I can do is I can take the square root, because the square root cancels out a squared. They're like inverse operations, okay? So if I square root this side, I also have to square root the other side. And what that allows me to do is find just c. Okay, so what is the square root of 25? 5. Good. Okay, if you weren't sure how we found that, it's what same number times same number makes 25, right? It's 5. Now, sometimes we might get a number where we can't think of the answer to the root in our head because maybe we get a number like 27. There is no same number times same number, like a whole number that makes 27, right? So that's when I put it into my calculator and do the square root on my calculator, and I round to the tenths place, just like what we've been practicing, okay? All right, I want you guys to try this one right now. Okay, so I'm going to give you guys a minute to try that. All right, so check your work. How'd you guys do on that? Raise your hand if you got it right, please. Okay, nice work. Okay, so we're going to skip this one, and we're going to go down to the next row, and we're going to take a look at this one right here. Okay? All right, so in that one right there, let's start out by labeling all the parts. So here's your right angle. So where is C? Which number up there represents C? 17. It's across from the right angle, right? So this is your value for C. Does it matter whether I call this one A or B? No. What do you guys want to call it? A. A? Okay. So if this one's A, then this one down here is going to be B. So I'm trying to find B right now. So let's go ahead and plug everything into the formula. So I'm going to plug in 8. And I'm going to plug in 17. Okay, and now what is 8 squared? Okay. What is 17 squared? 289. Is that what you guys said? Okay. Now, look at this one. On this one, we kind of have to do an extra step to get the numbers together on the same side of the equal sign, right? So, what do I have to do to get the numbers onto the same side of the equal sign? Yeah, subtract, right? I'm going to move this one over here so that the variable stays over here on its own, okay? So I'm going to subtract 64 from both sides. Okay, so I get b squared equals, was that 225? That? Is that right? 289 minus 64? I think it's 225. Yeah. Okay, so now take your square root of both sides. Did you get it, Jace? Yeah. Yeah? Okay. All right. So b equals what? Is it perfect, this one? Yeah, what was it? 15. Okay. So our missing side is 15. 15 is the answer. Okay? All right. I want to give you guys a minute and try this one. Okay? I'm just telling you on this one right now that when you take the square root, it's not going to be perfect, so you're going to have to round to the tenths place, okay? So you should have like a number and then another number after the decimal point. Does that make sense? Okay. Go ahead and try that one. Okay, go ahead and check your work. Okay, take a look at the steps. How did you guys do? Raise your hand if you got it correct. Okay, most of you. Very good. Okay. All right, we're going to leave this other one blank, and then we're going to flip to the back side right now. Okay, so everyone flip over to the back. All right. Now, one of the things that we can use Pythagorean Theorem for is solving problems. Solving problems where maybe we're like dealing with real world situations or objects and we need to figure something out. And so if the objects or the shapes that we're dealing with form a right triangle, then we can use Pythagorean theorem to help us figure out something that's missing. Okay? So in this type of problem where we're doing a word problem, the number one thing that you should do to start after you read the problem is you should draw a picture. Okay? The very first thing after you've read the problem, draw a picture to help you see what's happening. Okay? So we're going to read the problem first, and then we're going to draw a picture. So the problem says the bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? Okay, so let's go ahead and draw a picture of this. We're basically taking a ladder and leaning it against the wall. Have you guys seen that in real life before?
Oh yeah, that it forms like a triangle.
Yeah, and it forms a triangle, right? But like, I had to do this over Christmas time to put up the Christmas lights on the house, right? Lean the ladder against the wall and then staple or hang or whatever the lights on the eaves of the house, right? Okay, so if you think about how the wall is, here's the wall, right? And the ladder is not just floating in air, it's on the ground, right? So here's the ground. Does that make sense? And we're taking this ladder and we're leaning it against the wall, so it's doing something like this, right? Here's your ladder. Okay? And it's leaning against the wall. Okay. What angle do the wall and the ground create here?
Right angle.
Right angles. So I can label this 90 degrees. I mean, at least the wall of your house and the ground should create a right angle. If it doesn't create a right angle because the wall's leaning, that means it wasn't built very well, right? Okay, so it should create a right angle. All right, so now let's look at the information they gave us. It said the bottom of the ladder, here's the bottom of the ladder, must be placed 3 feet from the wall. So here's the wall, so this distance here, what can I label this? 3 feet. Okay. All right, then it says the ladder is 12 feet long. Well, where's the ladder? This side, right? Yeah, the hypotenuse. So that's 12 feet. Now it's asking how far above the ground does the ladder touch the wall. So this is where the ladder touches the wall, right? So it's wanting to know how far above the ground is this. So it wants to know what is this distance here, right? Okay, but that's a missing side. Is that a missing hypotenuse or a missing leg? Leg. Do you guys want to call that A or B? A? Okay. Let's call this one B then. And let's call this one, because it's the hypotenuse, what? C. Okay, so now that I've drawn my picture and I've applied the information to the picture and done some labeling, now I can just use Pythagorean theorem. So Pythagorean theorem, remember, says a squared plus b squared equals c squared, right? So I don't know A. I do know B. And I do know C. Okay, so let's go ahead and work those out and see what we get. What's 3 squared? And 12 squared? 144. Okay, the numbers are on different sides of the equal sign, so I have to subtract first to get them together. So let's go ahead and subtract. Okay, and then what do I get for 144 minus 9? 135. Okay, then I'm going to take the square root of both sides. Okay, this one I believe is giving me a decimal, right? So let's see what we get. Okay, the square root of 135 is 11.61. Do I need to round up or leave it alone?
Leave it alone.
Leave it alone, okay. So just 11.6. Now, what unit of measurement am I talking about here? Feet, right? So my answer is a number of feet. So this would be my answer, okay? And if it's a word problem and they give you a unit of measurement, make sure you use a unit of measurement in your answer, okay? So the question, how far above the ground does the ladder touch the wall? It touches 11.6 feet above the ground. That's your answer, right? Okay. Are there questions on how we did that one? Okay, does anyone need more time writing that one down? Okay, let's go to the next one and take a look at that one, okay? So the next one says the area of a square is 81 square centimeters. Find the length of a side. Find the length of the diagonal. Okay, so what kind of shape is it talking about here? Okay, everyone draw a square. What do you know about squares?
They have 4 right angles.
They have 4 right angles. Okay, all the angles are right angles. What else do we know about a square?
They have 4 sides.
What about the 4 sides?
Each has the same length.
Yeah, they're all equal. They're all the same, right? Okay, so I know the area of this square. The area, they told me, was 81 square centimeters, right? Now, how do I find the area of a square? What do I end up doing to find the area of a square?
You have to multiply the sides.
Multiply the sides. But the sides are the same, right?
Yeah.
So what times what makes 81?
9.
9. So each of these sides has to be 9, right? All these sides are 9, because 9 times 9 makes 81. Does that make sense how we found that? Okay, so did I just answer the first question? Find the length of the side, okay? So a side is 9 what?
9 centimeters.
9 centimeters, okay? All right, now, the second question, find the length of the diagonal. So let's draw in the diagonal. Diagonal means from corner to corner, right?
Yeah.
Okay, so this diagonal that I'm drawing in, and maybe you guys can see it better now. Can you see the right triangle here if I cover this part up?
Yeah.
Okay, so what part of the right triangle is this diagonal?
Hypotenuse.
C, the hypotenuse. Okay, so now let's use Pythagorean Theorem. A squared plus b squared equals c squared to find the hypotenuse. So can you guys plug that in
Yeah.
and solve?
The A and B are equal to 9, right?
Yes, a and b in this case are the same length, right? They're both 9. Okay, so what did you guys get for that square root when you did that? 12.7? Yeah, about 12.7, right? Okay. So, the second question was asking us find the length of the diagonal. Okay, so the diagonal, and I'm going to put it's about equal to 12.7 centimeters. Okay, so these are my 2 answers right there. All right, are there questions on how we did those 2 problems?
No.
Anything from those? Okay, does anyone need more time writing anything down for this one? Okay, we're going to skip these 2, and we're going to go to do some of these ones here. So we're going to look at this one first. Okay, so that one right there says determine whether the triangle is a right triangle. Okay, so we're trying to figure out, is the triangle a right triangle? It looks like a right triangle. It looks like a right angle here, right? But there's nothing marked here telling me it's a right triangle, so I'm not sure. So let's go ahead and let's see if I label these like A, B, and C, and I put them in the formula, if they actually end up working out so that the formula is true. Okay, so which one of these would be the hypotenuse if this were a right triangle? 16. Okay. All right, then which one do you want to call A and B?
14.
14a.
Yeah.
Okay, and this one b.
Yeah.
Okay, so let's plug these things into a squared plus b squared equals c squared. So a squared plus b squared. Now you're going to take this whole thing, I know it's kind of a weird number, square root of 56, and you're going to put parentheses around it and square it. Okay, equals c squared. Okay, now what is 14 squared? Some of you are probably doing it on your calculator. What was it, 196? Okay. Now, how many of you are like, I don't know what to do with this? Okay, remember, a squared and a root, they're like inverse operations, so they basically cancel each other out. So if the root and the squared are inverses and they cancel each other out, what's left here? 56. Whenever you have a square root squared, the answer is just what's inside the root, okay? Because those two things basically undo each other, okay? All right, and then this one, 16 squared, gives me what? Okay, so now I'm going to go ahead and put these together. Is this a true statement? No. Okay. So what happens if I get a statement and it's not true? It's not a right triangle. Okay. So we're going to say for my answer, no, it is not a right triangle. Okay. What were to happen if I did get like 256 equals 256? Then what would that mean? Then it's a right triangle. Okay. Does that make sense on that one?
Yeah.
Because if it's a right triangle, it has to, Pythagorean theorem is always true for any right triangle, so these two sides would come up equal. Okay? All right, so let's take a look at this bottom problem, the last problem down here. Okay? All right, so on this bottom problem, it says a triangle has sides 3, 4, and 5. Is it a right triangle?
We don't know.
So we don't know, okay? But let's plug these numbers into A, B, and C. Now be careful here because they didn't give you a drawing. So which one of those numbers has to be the hypotenuse? Why? Why is 5 the hypotenuse?
It's the biggest number.
It's the biggest number. It's the longest side. So I'm going to use A, B, and C for these, okay? So we're going to go ahead and plug it in. 3 squared plus 4 squared equals 5 squared. Okay, what is 3 squared?
9,
And 4 squared?
16,
And 5 squared.
25.
Okay, now combine this side. So what do you get there?
24.
Okay, is this one true?
Yeah.
Yeah, that one's true, right? So what's the answer to this one?
Yes, it is right.
Yes, it is a right triangle. Okay, are there questions on anything that we went over today or anything we covered at all?
No, it is easy.
Okay. All right, your homework tonight is you have a worksheet in your packet that I gave you called Pythagorean Theorem worksheet. Your homework is to do the whole worksheet front and back. There's 2 sides to that worksheet, okay? All right, that's due tomorrow.